Okay, in this video, what we're going to be doing is we're going to be using our debugger to download the code that we just built in CubeIDE into the target, into our Nucleo board. So back here at Cube, we can see that we've built the code. So you got to obviously you have to have a build. You have to have this ELF file, and then what you're going to do is you're going to hit this little bug. And we're going to download into the board. Now, what's really going on here, and if you had a vanilla version of Eclipse CDT, you'd have to come in here into the debug tab, and you'd have to, or the debug dialog, and you'd have to create a debug configuration so that it would know what to do when it's talking to your target. Now, in the sort of ARM Cortex-M world, I tend to use something called OpenOCD, and so OpenOCD are there some ST-Link software, but I believe this particular thing uses CubeIDE uses OpenOCD in the background, and so what that OpenOCD is it's a tool that's used to connect between the debugging hardware on the Nucleo board over USB to your host, right? It basically manages that link and sends those low-level messages to the target hardware. And on the other side, on the host side, it exposes a port so that GDB can connect to it, right? So it allows us to, at the IDE level, or at the CubeIDE level, it's allowing us to use GDB commands and send GDB messages to the target, things like dump the memory or dump the instruction trace, those sorts of things. And so we can send GDB messages along those lines. All right, so we're gonna use it as a tool here. We're not gonna have to worry about setting all that up. And so let's click on it, and there's some dialogues that won't necessarily show here, but I clicked on that button. You can see down here it opened up this debugger port, and there we are. You can see that now we are in what's known as a different perspective. And so the perspective is something where the windows are in a particular arrangement with maybe different windows that you don't necessarily need when you're in a different perspective, but there are a number of different perspectives here that I've got showing. I've got a C++ perspective. That's for writing and building your code. And then I've got a CubeMX perspective. That's for looking at that configuration file. And then I've got a debug perspective, right? So over here, I've got things like variables that I might be looking at, or expressions, or the breakpoints that I might have set. And so if I were to want to start and stop this code, there are some tools up here, and again, these are all hotkeyed, so you can do this, and you will with function keys. You can and you can change those if you don't like them the way they've arranged them. But if I just were to go ahead and hit this resume here and cause this to just start, hit resume. You see my mouse there. Hit resume. And I were to let it run, of course, this code doesn't do very much. So let's go ahead and stop it here. I'm going to suspend it. And you'll see that I'm sitting down here at this while loop, right? And so the template code for Cube, and I'm not talking about the examples, but the template code, all it does is it fires up the HAL, initializes the peripherals that you have told it to that you've told it to initialize implicitly in this case, because we've told it to initialize the things that are relevant to the Nucleo L432KC board when we created that project. So it does that. This GPIO is really initializing that LED, the LED GPIO, and then this here initializes the UART pins. And so the other thing I can do here, which might be interesting down the road, is you can disassemble this code. So those of you who are hardcore assembly language aficionados, here you are, you're sitting here at this, and you're just basically branching back to this location in Flash, and it's just sitting there doing it, and you're seeing it's woven source code with the assembly language. All right, so let's this thing up here, if let's say we want to go back to where we want the thing to reset back to the beginning, I can hit this little reset here, and I'm back up at the top. you can come down here and you can, let's say I want to set a breakpoint here. I can right click and I can toggle breakpoint right there. Notice it shows that little arrow here. Now when I hit run, I'll run and I'll stop right there, right? And let's say that I'm interested in understanding what's going on inside of that function. I can use this little step into, and it'll take me there. And so now I can step into these this structure right. So I can I take a look at okay, it's running at 115 200 is the baud rate, and I basically in this sort of the way ST has constructed their HAL, you basically load up one of these structures and then you pass it to init and it just does all the stuff that you have configured here. So basically that's their model of configuration for all the peripherals. So you'll see this paradigm will repeat where they'll have you load a structure of a particular type and then you will call init. And so so when I'm done looking at this. Let's say that I want to just jump back out of this function. I can step out and now I'm right back after the init. So I'm here. So this is a sort of proof positive that, okay, yeah, we've got control of the board. We were able to build something. We were able to download it to the board. We were able to step and work with the board. When you're all done, you can hit terminate, and it will terminate not only the sort of, it'll terminate the debugging session, and it will drop you back into C++ perspective. So now you can go back in and manipulate your code as you see fit. So we could make a change to the code. We could add some incidental line here. We could save it. We could rebuild it, and then we could return back to that. And so one of the things it has to do, of course, in the embedded space, even though that change was trivial, it'll still go ahead and download the code. And so we're right back here. I didn't make a significant change, but it was, it's not sure. I guess it could check the executables, and they should be the same because this change that I made should have gotten washed out in the compilation step. So yeah, so we're back right in this, and I can when I want to return, I can just terminate it, and here I am. I'm right back in. So okay. So that is the basic sort of flow that we're going to work with. In the next video, what I'm going to do is I'll show you how to get the things that you need to be able to print and get textual output out. One of the things that we'd like to have in this particular system is a way to receive characters on the serial port and to send characters on the serial port, so we can build a little command line interface for our hardware. So next time, that's what we'll focus on.